W6WUH. Here we are the day after the 4th of July 2022, and I've got the TenTec Titan II, the Model 416 amplifier, on the workbench. I made a video of the insides of this a year or two ago, and it's sat out on the outer workbench waiting for me to get to it. I had a problem when I first tried to fire it up. I bought this from a Silent Keys estate. When I first tried to fire it up, the fan would not come on. The timer didn't seem to allow the B plus to come on. So I set it aside. I put it on the workbench a couple of days ago, and I somewhere along the line I'd pulled all the little plugs off of the circuit boards here, and looked at them, shot them with deoxit, and I just took a screwdriver handle and tapped on these power control relays here. This is the AC control board, and up here's a little tiny Omicron relay that's part of this circuitry. And I just tapped on them with the screwdriver handle, and as I said, cleaned all the plugs, and decided to plug it back in and see what happened. And I had unsoldered the fan and tested it with 110 to make sure it worked, and the fan is fine. And when I put it back together and tried it, lo and behold, the fan came on, the timer did its 3 minutes timing, and then the B plus came on 3,000 volts, all nice and quiet and sweet as you please. So what's going to happen now is, as you saw in that previous video, there was some kind of apparent overheating incident in the PA tank, and it got hot enough that the soldered connection between the ring that connects to the external anode, to the plate of the tube, and the little parasitic board, that got so hot that the solder melted out of it and dripped onto the chassis. So what I'm going to do now, it hasn't had a B plus on it for 24 hours. I'm going to go in there and inspect that PA tank circuit and resolder that parasitic board, and then we're going to hook it up with a dummy load and try it with about 10 watts of drive and see if we've got a good tube. So I've got my fingers crossed that this thing is going to work all right. The screen, the circuit will be all right, and all the rest. So we'll see what happens. I'm going to flop this thing over, screw the bottom on, flop it over, and we'll look in the PA tank circuit, and you can see me as I do the repairs, and then we'll hook it up and try to smoke test it. Okay, we've got the amplifier turned around here where we can get at it, the PA section, more easily. But we'll just take another little overview in case you haven't seen the other video, and everything looks pretty good. There's some evidence that this tube got hot. There's a little bit of discoloration on one of these tank coils over here, just a little bit, but in general it looks quite good. Everything else is fine. But what happened here, that is a puddle of solder. Get a pointer here. That's a puddle of solder there on the chassis, and it came from where this tab solders onto this parasitic board here. This ring here connects the plate voltage to the anode, the external plate tube, and this ring here connects to it like a hose clamp and solders onto this board, and so the RF and the B plus have to pass through that board to get to the tube, and that got hot enough to unsolder it. So I'm going to clean that up, fix that, and then we're going to put a low amount of drive on the amplifier with a dummy load and see if things are working properly. Okay, so now we've got this tab resoldered here. I had to use a soldering iron on it. And of course, gravity's not your friend. So it dripped a bunch of solder down there. Basically, you're trying to sweat solder this tab to that big plate on the circuit board, and you have to actually get it hot, sweat the solder under there, and clamp it with, you have to push on it with a screwdriver to make the gap very small and wait for it to cool. I went after it with some alcohol and paper towels and got all the old flux off. It may be that somebody else had tried to solder that and dribbled a bunch of solder there. I don't know. If this ever comes loose again, I'm going to drill a small hole through that tab and put a number 4 brass screw and nut through there and clamp it down good, and then sweat solder it, and that'll be the end of it forever. But anyway, I think it's going to be fine. Got it all nice and clean. No little bits of solder, no leftover flux, no crap. And just to put a damp rag over everything, because it's been sitting there kind of with the lid half on and half off for a year. So we should be good now. I'll go through with a screwdriver and a little wrench. Make sure that all of the mechanical connections are absolutely tight on this thing. I can't see any other mechanical faults, and the only way we're going to find any other electrical faults is going to be to fire it up. The timing, the relays, the power supply are all doing what they should do, so now we have to try it with some RF. But I'm just going to go through and just make sure there's no mechanical issues with any loose RF connections before I do anything else. Okay, we had one last look in there, and you know, you don't want to leave stuff, where is that, like this, floating around in your amplifier. So before, if you get a new amplifier you're not familiar with, take it apart and clean it, look at it. And if you work on it, make sure you get your solder blobs and crap out of there. So I went through here with little wrenches, nut drivers, screwdrivers, and made sure all the RF connections were tight. And I actually found one that was a little loose right here. But all the RF is going through that point for sure. It was just a little loose, and I just snugged it up. But you know, if you let things like that get loose, they'll arc down, and you really have to pay attention, follow everything through. Down in the bottom here, the bottom of this coil connects to this coil, and there's a Phillips head screw there. And here's a nice little one that's kind of tough. You don't want to ignore any of these connections. RF bypass caps down here on the chassis, make sure those are good and tight. Connection from the plate choke to this parasitic board, got to be good and tight. Parasitic board to the plate of the tube, everything good. B plus feeding through here, everything nice and tight, and then you're going to be happy. Okay, W6WUH. So what we've got here is the Yaesu ST450 set up to drive the TenTec Titan 2, and we've got the output set for about 10 watts, which is about the minimum amount of drive that the manual says this thing will function with. We may have to run it up to 20 or so, but I can run the drive up just by twisting the knob, and here's the reading here. So we'll start with 10 watts. We're looking at just about nothing for reflected power, and of course it's going through, looping through the amplifier to the dummy load. The amplifier is plugged into a 20 amp 240 circuit. It's number 12 wire with 20 amp breakers on it, so we got a 1,000 watt dummy load here. So I probably won't be, I'm going to try to test this and tune it up at maybe 300 watts power. Should be about 30 times amplification factor. So 10 watts should give us about 30. And if that tunes normally, then and it works good, screen current, grid current are good, tuning is good, then we'll increase the drive power. I've got the AC interlock micro switch jumpered back here, and this is a crowbar shorting for the B+, and when the lid is on there, it pushes down on that, it keeps it from shorting. So I just have that flopped over. I'm going to stay well away from this goddamn thing. I've got the lid off because if there's any arcing or any smoke or any problems, I want to see where it's coming from right away. So I'm going to turn this thing on now. It's got a 3-minute warm-up cycle, and so there's going to be nothing to do here but wait 3 minutes. I'll edit it out, but I'm going to leave the camera going. You can hear the fan going. Takes some time to get up to speed, doesn't it? And got this meter right now showing plate and screen current. Of course, there's no plate current yet. It's in the standby mode and it hasn't been timed out. But you can feel quite a bit of air coming through there. There's a sheet of paper, it's a fairly stiff sheet of paper, and you can see how much air is coming out of there. Quite a bit. Quite a bit. I haven't actually run it with the bottom on and the bottom sealed up like that, and yeah, you can hear it slow the fan down if you close it up. So there's a lot of air moving through that tube. It's just as there should be. So this is the wait light here, and it's really got a 3-minute wait time. And when it decides it likes it all and everything is groovy, basically letting the cathode heat up in the tube, I think. That light will go out. And there still won't be any B+ on the meter until we... oh, there's the wait light has gone out. All right, I'm going to put this in the operate position. First I want to preset the tuning and loading. We're going to do this on 40 meters. Select the right tap, and the loading should be about 3, and the tune should be about 1. So that's going to be pretty close to where we should be. I'm going to put it in the operate position, and we'll be able to read the plate voltage. There we are, and that's a little under 3,000 volts, which is not too surprising. I'm assuming we have some line drop out here, but that's just about right. And now what I'm going to do is set this meter to read screen current. We got just a little bit of indication there. That means a screen supply, and here comes, this is the Holy Grail. This is the by God moment where we're going to give it drive for the first time, and either we're going to see some power on the meter here and I'll be able to tune it, or the whole thing will blow up in our face. So here goes. Aha! So we're seeing RF power. So here's the screen current is okay. So I'm going to tune for max power. We're just about there. Then we're going to tune for minimum screen current. Power goes up. Okay, W6WUH. Testing the Titan 2. Got 10 watts of drive power. It's tuned up, and you can see the screen voltage is almost nothing. Got it peaked. Okay, screen current. So now we're going to run the drive up to 20 watts, and we're showing about 1,000 watts of output here. Let's look at the screen current. Screen current still just about nothing. There's the screen current there. Run it up to 30 watts. There's the forward power, over 1,000 watts. Look at the screen current. Still almost nothing. It says you're supposed to tune this for minimum screen current. 1,000 watts with 30 watts of drive. Until it gets plenty hot. Run it up to 40 watts of drive. $1,500 watts. Look at the screen current. Still almost nothing. Tune for minimum screen current. There we go. Almost no screen current at all. This is a really, really good tube. 40 watts of drive. Almost 1,500 watts of output power. Tuned for minimum screen current. Now we're looking at about 800 watts. I don't know. Screen current is so low that not worth talking about. 1,400 watts with 40 watts of drive. So there is one really good amplifier. Maximum allowable screen current on this thing is up here at 50-55 milliamps, and we're not even looking at 5 milliamps of screen current. So this thing is working extremely well, and right on the numbers it said the suggested loading and tune and load settings for 40 meters were tune 1, load 3. That's down at the bottom of the 40 meter band. We're in the middle of it, and we're at 1.5 and 2.75. Very, very close. So there you go. That's not going to do that to our poor old dummy load for very long. But let's look at what the how much the plate voltage drops here. This is more of a test of my line current regulation here. We're just at I don't know, 3,000 volts, 2,900 volts, and we're going down to 2750, something like that, when we're putting out 1,400 watts. So that's right what it's supposed to do. A couple of hundred volts a drop. That's real groovy, real groovy. So we got ourselves a nice amplifier. I was worried about the condition of this tube, but when the grid sensitivity is high like this, and the screen current is extremely low like this, that's indicative of an extremely good tube. If the tube was weak, the screen current would be high and the grid drive requirement would be high. Neither one is the case here. We drop this thing back down to 10 watts of drive. I think we're still going to see over 300 watts of output. Let's see. Yeah. Four hundred watts of output or more with 10 watts of drive. It's just extremely good. And the screen current, Zipola.